All right, y'all. So 7.1 deals with symmetry. And remember, symmetry, you can see that a lot in art and everything, but symmetry is where one side looks like another side, like on the human body, our left side symmetric to our right side, and so on. So we're going to look at 3 types of symmetry for graphs. So the first type of symmetry we'll look at is what we call symmetric to the y-axis. So symmetric to the y-axis. So to check symmetry for the y-axis, if I take the graph and fold it over the y-axis and the right side lands on the left side, then it is symmetric to the y-axis. So if folding the graph over the y-axis and the right half lands on the left half. Or you can say the left half landing on the right half, depending on which way you fold it. But if the right half lands on the left half, then it is symmetric to the y-axis. All right, also an example of a graph being symmetric to the y-axis. Would be the parabolas we've been graphing. So say I had a parabola coming up off the y-axis. So notice if I was to take this graph and fold it right over that y-axis, this right half would land right on top of that left half. All right, y'all, next we'll look at the x-axis. So symmetric to the x-axis. Oh, and y'all, one more thing up here. They'll ask us about even and odd functions. If it is symmetric to the y-axis, this is what we call an even function. What an even function means is that to get graphs that are symmetric to the y-axis, the exponents will be even numbers. Like remember, this is a parabola, so that would be the x squared graph, an x4 graph, x6 graph. Since they're even exponents, those would actually be what we call even functions. All right, y'all, so getting back to the symmetric to the x-axis, I check it the same way, except this time I take the graph and fold it over the x-axis. So if folding the graph over the x-axis and the top half lands on the bottom half, then it is symmetric to the x-axis. All righty, also let me draw an example of that. So here's my x and my y. Okay, got one in real quick. All right, so a graph that would be symmetric to the x-axis. I'm going to draw the parabola again, but I'm going to draw the parabola sort of laying down sidewise. So notice if I took my graph and folded it straight over that x-axis, the top of this graph would land exactly on the bottom half. So y'all, do y'all have questions on those two?
No, that seems pretty clear right there.
Yep. So the next one is a little different. This is what we call symmetric to the origin. So remember, the origin is the center of the graph where they connect the two X and Y axis. So to check symmetry to the origin, I do it a little different. What I do is I take the graph and I turn it 180 degrees. So if rotating the graph 180 degrees, which is half a circle, and you end up with the same graph. So if I turn this graph 180 degrees and I got the same looking graph, then it is symmetric to the origin. All right, so an example of one being symmetric to the origin. So my x cubed graphs, the x cubed graphs will come up, they'll pass right through that center, and then they'll go uphill. So the x cubed graphs, that's that squiggly curvy line y'all been using in graph when you've been playing in math lab. So y'all look at this picture. This graph is going uphill, left to right, passing right through the center. If I take this graph and turn it upside down, notice it still comes up from the left, goes through the center, and then goes uphill. So I got the same exact looking graph I had when I started with it in its original position. So if we can flip it and it looks the same, then it is symmetric to the origin. So y'all, what we're going to do now, knowing these three things here, symmetric to the y-axis, x-axis, and origin. Now, symmetric to the y-axis was even. Symmetric to the origin, those are what we call odd functions. Which means the exponents, the leading exponent on the odd functions will be odd, like an x cubed, x to the fifth, and so on. So what I'm going to do now is I'm going to go into the math lab, and we're going to knock out those 5 homework problems for 7.1, and I'm going to let y'all answer these. So let me share that page. All right, so y'all should be seeing my question number 1 now. So this is on y'all. But I want to know, and y'all let me make it just a little larger for you. I want to know, is this graph symmetric to the y-axis, the origin, the x-axis, or if there is no symmetry? What would y'all go with?
B.
Oh, what did you just say?
Is it the origin?
The origin, definitely the origin. Because see how it's sort of going down and up and then down. If you turn it upside down, this bottom part would be on the top and it would still do that same pattern. So good job. That is definitely the origin. So y'all, you would check that, move to the next one. All right, y'all, same question.
Isn't that why? Because if you fold it over, it would be the same, right?
Exactly. So that right half, if I folded it along the y, the right half definitely would land on the left side. So that is definitely the y-axis. And if I fold it over to x, well, it's not landing on itself. It's landing in a space where there wasn't even nothing to add. So good job. All right, y'all, we hit our next question. So all we want to know on this one, they're starting out with the x-axis. So this will go through 3 steps. So first of all, is that symmetric to the x-axis?
Yes.
That's a yes, right? And that would,
Yeah.
okay.
There you go. Because if you fold it over to x, that top half would land exactly on that bottom half. So it's definitely symmetric to the x-axis. And then let's see, I think it'll go through the next one. Is it symmetric to the y-axis?
No.
No, good job. Because I don't even have a graph on the other side of the y-axis, right? And then lastly, is it symmetric to the origin? So if you turn that paper 180 degrees, will we have the same graph in the same position?
Yes.
No, right? Because if we flip it over, the blue line would be on the right side of the graph, where it's
There
on
you
the
go.
left side now.
There you
Okay.
go. Good job, y'all. So good job on that one. All right, this is going to go into the even and odd. So remember where I said was even and what I said was odd. So for this function, I'll make it a little larger for you.
It'll be even, right?
That is definitely even because it's symmetric to the
Y-axis.
Right.
There you go. So remember, if it's symmetric to that y, it is definitely even. So y'all, you're gonna love this 7.1. It's not that bad on its homework. All right, how about this one? Let me make this a little larger for you. So is this one even or odd?
Odd.
Or neither?
Is it neither? Because you've got to, this is the one you flip over, right? Or am I wrong? Am I wrong? Am I
Well,
not understanding?
We know it's not even because it's not symmetric to the y. But remember, if I want to check for an odd functions are symmetric to the origin. So if you flip this one 180 degrees, would we still have the same picture?
Yes.
So that means this,
Yes.
then that means this one is
Okay.
a
It's odd.
Odd.
There you go.
Well, thank you.
Mhm. Now, the ones that are symmetric to the x-axis, those ain't those ain't even or odd functions, because if it's symmetric to the x-axis, it violates the function rule, remember? Remember, the functions, to be a function, all the x values can only have one y value. But the ones that are symmetric to the x-axis, they got at least 2 y values, so they're not even a function, okay? All righty, y'all, so let's go back now. Let me save that. Oh, I guess it's telling me I can't do that since I'm in preview mode. So let me pull something up. I'm just gonna get the next homework ready and then I'll come back to my pad. All right, so let me get my share screen in the bag. So now we're going to look at 7.2 for college algebra. And I won't do all the problems in this one. This one's probably got 9 problems altogether, I think. But the main thing I did want to do is show you how to use MATLAB to plot these graphs. So for 7.2, we're looking at what we call transformations. And transformations are going to be moving the graphs up, down, left, right, and reflecting them. So there's 3 transformations we'll look at. The first shift is up and down, so we call that a vertical shift. So to get a vertical shift, I'll have a graph in this form. Y equals my f of x plus or minus b. So what I do is I take a number and add or subtract from the end of my function. That's going to move me up and down. If the b is positive, if b is positive, it's going to move up. If the b is negative, it's going to move it down. So adding or subtracting from the end of the function. So an example, if I had y equals x squared plus 2, my function would be x squared, and I'm adding 2 to the end of it. This would move this would move x squared graph up 2 units. How about something negative at the end? How about an x to the third minus 4? Since I'm subtracting 4, this would move the x cubed graph down 4 units. And y'all, after I give you all these moves, I'm going to show you what the basic graphs look like the x squared, the x cubes, and so on, okay? All right, vertical shift, adding up, subtracting down. Next, we look at a horizontal shift. Now, out of the 3, this is probably my trickiest one, but those graphs will have this form. Y equals f of x plus or minus a. Notice the difference. Up here, I had my function x squared and I added a number to the end of it. This one, you're adding and subtracting from the actual x value being evaluated. So here's the 2 moves it'll do. If the a is positive, now this is sort of backwards from what you might think, but if that a is positive and you're adding a positive number to the x, it's going to move that graph to the left. And if the a is negative, it's going to take my graph and move it to the right. So adding to the a being evaluated left, subtracting from the a being evaluated to the right. So I'll give you a couple examples of that. How about y equals x plus 1 squared? So notice, it's still the squaring function, but now I'm attacking the x instead of adding the number to the end like I did up here. This will move the x squared graph. Remember, I'm adding, and we said if it's adding, it's going to move it left. So this is going to move the x squared graph left 1 unit. So let's subtract from our x. Let's do y equals x minus 3 to the 3rd power. So this is still my cubing function, but now we're attacking the x by subtracting from it. So this is going to move the x cubed graph right 3 units. So like I said, if you add or subtract after the function, up or down. If you add or subtract to the x before it's evaluated as the function, left or right. So y'all, that leaves us with our last move, and then I'm going to give you the basic graphs you need to know. The last move is what we call a reflection over the x-axis. So the graphs will have this form. It'll have y equals negative f of x. So that negative being put in front of my function flips it from positive y values and makes them all negative y values. So it's going to flip it right over that x-axis. So y'all, an example of that would be y equals negative x squared. What that would do is it would take your parabola and flip it over, and instead of it looking like a U, it'll sort of look like an N or just a mountaintop because it'll be flipped over. So those are the three things we're going to do: move them up and down, left and right, and reflect them over the x-axis. So y'all, we need to know the basic graphs so we can know what moves we're going to do to them. So I think there's like 6 or 7 of these. So the first one is a straight line. It comes straight through the center of the graph. This is the y equals x graph, and it's just a straight line. And what this means is if x is 1, y is 1, x is 2, y is 2, and so on, okay? Next basic graph is the parabola. The U-shaped graph, that is y equals x squared. So we always had the squaring graphs when we got our parabolas in math lab. Next, we'll do the cube. The cube comes up, goes through the center, and then goes uphill. This is the y equals x to the third graph. There we go. One more on this, and then I'll go to the next row. All righty. So I got one that looks like this. It comes in and goes down. Over here, it starts up there and goes down. Now, later on in life, you'll learn why these two sides are not connected. It has to do with this graph is a y equals 1 over x. So if you was doing a domain on this, x couldn't be 0. So that's why the graph can't cross 0 on the x-axis. I mean, on the y-axis, because it's undefined at 0. But you don't have to know that. Just know what that graph looks like. All right, we got one that looks exactly like a V. And the one that looks like the V is the y equals absolute value of x. Now, y'all, 2 more. This graph starts in the center and slowly goes uphill to the right. This graph is the y equals square root of x. Now, square roots, notice, are not on the negative side because you cannot take square roots of negative numbers. If we try to take square roots of negative numbers, that gives us imaginary answers. So that's why this one ain't got a graph on that left side. Now this one's sort of similar on the right side to the one I just did, maybe a little flatter, but it also goes on the negative side. Let me let one in real quick. This one is y equals the cube root of x. So what this means, you can take cube roots of negative numbers because you get negative answers, but you cannot take square roots of negative numbers. So y'all, these are the 7 basic graphs that we're going to be moving around in MathLab. So remember, vertical shift, I'll add or subtract at the end. Horizontal shift, I'll attack the A by adding or subtracting. Reflection, I'll throw a negative in front of the function. All right, y'all, so save this picture because we're about to go to MathLab and work some of these problems. Now, the only one that you have to physically plot in MathLab will be the y equals x graph. On this one, you actually have to get 2 points and plot it, okay? So I'm going to go to MathLab. All right, so y'all should be seeing my question 1. So it wants me to tell how a given function can be obtained by one of my basic graphs, and then we're going to graph it. So notice what they're doing. We can tell this one has an exponent of 2 sitting by it. So this is going to be our y equals x squared graph because of that 2 exponent. So the thing we want to know, we're attacking that x inside those parentheses by subtracting 2. So what I want to know is, by subtracting 2, is that going to move me left, move me right, move me down, or move me up?
Hello, I mean, it's gonna be right, ain't it?
It's going to be right. Good job. So you would come down here and pick B, the one that says shift the graph 2 units to the right. And down here where it says y equals, in the y equals, you got to put the basic graph, which was the x, and then click on your exponent and put a 2. So you start with the basic graph of y equals x squared. By subtracting 2, that's going to shift it to the right. So you check that answer. And then it's going to have us graph that. So I'm going to click on my graph. So remember, x squared graphs were parabola. So y'all, all you do, you click the x squared tool and then click on that graph anywhere. You can click anywhere and it'll put it in the center of the graph for us. And at that point, it looks just like our basic graph we drew a while ago. Now you notice down here on the bottom right, it opens up a box. Now we don't have to worry about the vertical stretch and shrink or the horizontal stretch or shrink. Only moves we're doing in here will be a vertical shift, the horizontal shift, and reflect over the x-axis. You can even ignore the reflect over the y-axis. We'll never click it in this section. Now, you said I'm going to move right 2, so that's a horizontal move. So you click on that little tab and you move it to the right 2 units. After I move that to the right 2 units, look at my graph. It now moved itself over to the right and is now touching at 2 on the x-axis. So that's the only move we did. We would save that and then check our answer. All right, y'all, so my next question, this is the one I was talking about. This is the x minus 3. This is the line graph. So by subtracting 3 at the end of my function, will that move me up, down, left, or right?
Down.
It's going to move me down. Good job. So if the x is not in parentheses with the number, it's going to be up or down. So you said down, and we start with the graph of y equals x. So y'all, like you did a while ago, you're going to check this one. Now, when this one has to be graphed, since it's a line, all we do is click the line tool and then find 2 points. So since that was x minus 3, if I let x equal 3, 3 minus 3 gives me 0 for the y. So I'm going to be at 3, 0. Click that. And then let's see, if I let x equal 0, 0 minus 3 would be -3. So when x is 0, I go down to -3 and click it. Now notice what it did. It was going through the center, but now by plotting my 2 points, you can see that it shifted my graph down those 3 units. So y'all, you would save that and check. All right, y'all, so get ready. Here we go. This one is the 1/x graph. So what is happening by subtracting 5 at the end?
And move down.
So again, it's going down. So let's see, that'd be D going down. Now, this one is not going to make you graph it, but watch, it'll give you 3 pictures. So A looks like the basic graph we drew a while ago. B looks like it went up. But y'all look at C. C looks like the graph went down. So we would pick C on that one and check. All right, y'all, so I'm gonna let y'all figure this one out. There's a negative in the very front. And then you're attacking the X, subtracting 9 from it, then you're cubing it. So let's look at the inside of the parentheses. I got an X minus 9. What is that doing to my graph?
Rotating,
Oh, what'd you just say?
rotating or reflection, excuse me.
Okay, so the first negative is going to reflect it. And then when you subtract 9 from the X inside the parentheses.
And move down.
Oh,
Right.
I'm not moving down.
Excuse me, right,
I'm not moving down. I'm moving to the
Right.
right.
right. There you go. So it's going to shift right 9 units, and then it's going to reflect across the X axis. So y'all be careful. C has a Y axis. We need to go with B on that one. Now, the basic graph, since you said exponent of 3 there, would be what? X to the 3rd. So when it says start with the graph, it has to be one of them 7 we drew while ago, okay? Now watch, it's going to make us graph this one. So remember, we went 9 right and we reflected across the x-axis. So the x cubed graph was the curvy line, and it'll say x cubed on it. Click that, click anywhere on that graph, it's going to put it in the center. So horizontally, we went right 9. So come down here and click this horizontal shifter to the right till you get it on a 9. Ooh, it's touchy. All right, I went right 9, so it moved my graph. Now, in the bottom left corner, since we reflected it over to X, we got to click that and make that check. Now, notice what it did to the graph. When you uncheck it, it's going uphill left to right. But when you reflect it, it's going downhill left to right. All right, y'all save that. And then you're checking your answer. So y'all, let me find one more of these for y'all, and then we'll go into our support stuff. So let me see. Let me look through these. Oh, how about this one? And y'all can answer this. So I got x plus 5 squared minus 2. So the first thing I want to know, what is the graph we're going to start with? F of x equals what?
X is X squared.
It's going to be x squared. So we did 7 of them while ago, and only one of them had that exponent of 2 on it, right? So good job. So you put in your x squared graph. Now it says shift it blank 5 units. So the 5 is inside those parentheses and it's positive. So by adding 5 to that x, is it moving me right, left, down, or up?
Would it be up?
No, because remember that 5 is inside those parentheses. So to move it up, your number would have to be out there where that -2 is. All right, so we're inside
Moving
of
right.
or you're on the right track, but remember when you add, it don't really go right, it actually goes,
Up. It's up.
Left.
it's gonna be left. There you go. Now, at the end, it says blanket 2 units. So down to 2 at the end, is that up, down, left, or right? So remember, 2 is like your B was while ago. The 5 is like the A was while ago when I gave y'all them 3 shifts, okay?
So it's up,
So you're subtracting 2, so, oh, I heard it, I think. What did you just say?
up,
Oh, not -2. -2 can't go up.
Down.
It's going to be down. All right, so I'm going to get you on another one. Let me graph this. So x squared graph is the U. Let's click it anywhere on here. So the +5 was horizontal shift left 5 units. And then what was at the end? A -2. So that -2, take the vertical and run it to a -2. So see how it moved it left and down? Save that. Check your answer. All right, so I'm gonna have to, let me see if I want y'all, let me see what we got here. Oh, let's do the radical. So this is a square root graph, and they're even telling you, hey, we're going to start with g of x equals square root of x. But what we want to know is when you subtract 10 inside a radical, you treat it like it's in parentheses. If I was going to move it up or down, that 10 would be outside of that radical. But since it's under it, you would treat it like it's in parentheses. So when I attack that x and I'm subtracting up, right, down, or left.
Left.
Oh, you're so close. Go the other way.
That. What the heck?
It'll be right.
It'll be right. There you go. And it'll go right at 10 units. So I will say this, when it attacks the x, that's the one that is backwards from what you think, okay? All right, so which graph looks like it went right 10 units? A, B, C, D. And just remember, all these graphs started right in the center. So y'all, let's see, if I'm looking at these,
Is it
A.
A?
yeah, A, because see, it started in the center, but it's way over here at 10. B, they went left 10. C, they went down 10, and then D, they went up. So we would definitely want A on that one. All right, so this one's different. This is a cube root of x, and they're telling us what we're starting from. So notice, this -6 is not underneath that radical. So I wouldn't treat it like it was in parentheses like I just did that last problem. So when that -6 is subtracted from the end of your function, left down, right up,
Down.
it's going to be down 6. Good job. So let's see, that would be A for me. All right, and I bet they got some pictures for this one. All right, so A, B, C, or D. And I'll tell you, B looks exactly like the basic graph because it's right in the center. So it's either going to be A or C that went down.
A.
A, so we would click our A and final check. Well, hell, I guess we're on the last one. We might as well do it. And this one's got 3 moves. And they're telling you you're starting with the x squared graph. So the first move is inside the parentheses where the x -3 is. They sort of do these like order of operations. So the x minus 3, is that moving me left 7, left 3, right 7?
Right 3.
So right 3, good job. Now, there's only one axis we're reflecting it across. So we're going to reflect it across the which one?
Is it the X?
It's going to be the x. And you say that every time, okay? So that's what that negative is doing in the very front. So now, outside at the end of my function, I'm adding 7. So is that going to up 7, down 3, up 3?
Up 7.
Up 7. So let's see, that would be up 7. Then you're going to check it. Now, I don't think we got to graph this one. I think it just had to have the moves. So y'all, that is 7-2. Them 8 problems there, okay? So not too bad. You just gotta use these shifts we got right here. And if it's inside parentheses, like the horizontal, plus is left, minus is right. If it's added at the end or subtracted at the end of the function, you're going up or down. And then putting that negative in the very front reflects you over that x-axis. And y'all remember, these are the 7 basic graphs that they're moving around for you, okay? All righty, so that is actually the college algebra part of today. What I'm going to do next is some questions that you'll see in support for 7.4. This is going to get us ready for college algebra 7.4 Thursday night. So this is going to be 7.4 support. Sometimes when they got more important support lectures, I like to give y'all examples of these. And this is just solving quadratic equations, which have the x squares in them. So for my number 1, we're going to solve 11a plus 6 times 5a minus 15 all equal to 0. So these are going to give me examples on solving by factoring in a second. And this is one of the final steps when you factor it, you get it to parentheses like this. So when you're at this point and you got parentheses equal to 0, you take both of these factors and set them equal to 0. And that's how you get the 2 answers. Because x squared graphs always give us 2 answers. So set both the factors equal to 0, and then you're going to solve both of these for the a. So really here I'll subtract 6. I get 11a equals a negative 6. And then I'm going to divide both sides by 11. So the first a is going to equal a negative 6 over 11. And y'all, the second one, I'll add 15 and then we'll divide by the 5. So adding 15 gives me 5a equals 15. And then we'll divide by the 5. And I get x equals 3. So in MATLAB, it'll say the solutions are, you'll put in negative 6/11, comma 3, and be done. Now, they did a problem like this because, like I said, that's one of the final steps when you're factoring. So let me ask y'all this before I do this next one. Are y'all familiar with solving something by factoring?
A little bit, yes.
Yeah, I think they might have done this in foundations, if y'all had foundations or something. So let me put a pause on number 2 for a second, and let me get y'all good at factoring. So this is going to be solving by factoring. And we also call this finding zeros. So solutions to equations when we factor are the same thing as finding zeros. Because to solve them, we set them equal to 0, okay? But what I want to do is bring back some memories on a little factoring. So I'm going to give us 4 examples of factoring and show you how I factor these things. So the first one, y'all, I'm going to do x squared plus, how about 11x plus 24 equals 0. So to factor these, we're going to bring them down in parentheses. Now notice this is a trinomial, x squared term, an x term, and then a number. So when you got an x squared in the front, both these parentheses will have an x in them. Next, I figure out what kind of signs to put in here. So y'all, here's the rule. If this last number is positive, both of these factors here will have the same sign as the middle number. So since my middle number is positive, both these factors will be positive. Now, to find these two numbers, what I need y'all to do is find me factors of 24 that add to equal 11.
3 and 8.
So that'd be a 3 and an 8. So you would just put your 3 and 8 in here. And now we're factored. Now to check yourself, 3 plus 8 is 11. 3 times 8 is 24. Now see, this is the point where that first problem was. They got me in parentheses. So I would take both of these factors and set them both equal to 0. And y'all, you're going to learn one thing. All we're doing here is changing the signs. So the solutions will always have opposite signs than your two factors. Because look, my first one was positive, but the actual answer is a -3. The second one had a positive 8, but y'all, when you subtract 8 and move it over, it becomes a -8. So for this one, your answers would be x equals -3, -8. And like I said, these solutions will always have opposite signs than the factors. All right, y'all. So this was when everything was positive. Next, I'm going to do some negatives. How about a negative? Well, I'm going to do negative 11x again, but now I'm going to do a positive 30 equal to 0. So we'll set up our parentheses. I got an x squared, so that's going to put an x and an x. So y'all watch this. The last number is positive again. So since the last number is positive, both of these factors will be negative like that middle number. All right, now the last number is 30. You got a 30 there? I need factors of 30 that add to get that 11.
Six and 5.
So 6 and 5. Now, although they're both negative, we knew that because of this middle sign. So when you're getting over here, you're just looking for the factors that'll equal 30 when you add them. I mean, will equal 11 when you add them. Now over here, since I already have my signs, -6, -5, add to get -11. -6 times -5, multiply to get to 30. All right, so that was factored form. Remember, I'm going to get the final answers by solving for the x's. And y'all, once again, all I'm doing is changing the signs from both of them being negative to both of them being positive now. So the moral of the story, well, one must have got knocked off. If the last number is positive, they're both going to be the same sign as the middle. Last one's positive, both factors were negative like the middle. So let me do one where the last number is negative. How about x squared plus 7x minus 30 equals 0. So y'all, this is going to start out the same way. I'm going to factor this in parentheses. I got an x and an x. So let me ask you this. Since this last number is 30, what kind of signs when you multiply give you a negative?
Opposite signs.
Opposite signs. So that means one of these is positive, one of those is negative. Now watch how I get, since the last one is negative, I'm going to take factors of 30, but now I want factors of 30 that'll subtract and give me 7. So what?
10 and 3.
Oh, what did you just say?
10 and 3.
10 and 3. But y'all, I don't know where to put the 10, where to put the 3. So here is the rule when the last one's negative. Find factors that subtract. The larger of these two factors has the same sign as the middle number. So larger factor, same sign as the middle number. So since 10 is my larger number, it's going to be positive like the middle number. The 3 will be the negative. So y'all watch this. 10 and negative 3 equals 7. 10 times negative 3 equal that negative 30. All right, now set both of these factors equal to 0. So the first one, we'll just subtract 10. And then add our 3. So once again, opposite signs, then these two factors. All right, so let me pull my camera down and we'll knock out one more of these. Everything's going to be negative on this one. X squared minus an x minus 20 is going to equal 0. So y'all, once again, that last one's negative. So what's that tell me about my factors? Only way to get a negative when multiplying, and it's still going to be opposite signs. So one of these is positive, one's negative. All right, y'all, got a 20 at the end. What number's in the middle?
-1.
That's going to be a 1. And I don't even care about the negative at this point. All I want is factors of 20 that subtract to get a 1. So what factors of 20 subtract to get me a 1?
5 and 4, I believe.
5 and 4. So here's a question. You think I'm going to make that 5 positive or that 5 negative?
Negative.
I'm going to make it negative. Good job. Because like we said right here, the larger factor, which is my 5, has the same sign as the middle number. And then if you add them, -5 and 4 equal -1. 4 times -5 equal -20. All right, so I would subtract 4, give x is a -4, add 5, give x is a +5. So y'all, that's the 4 rules on the signs. If they're both positive, both factors are positive. If the middle's negative and the last number is positive, both are negative. That's the only way to get 2 negatives. If the last one's negative, they're unlike signs. The larger factor will be positive like the middle. This one, the last one's negative. I got unlike signs. The larger one will be negative like the middle. All right, now, so now we can go back and start solving these problems I was about to solve, okay? So that bring back some memories now doing that factoring?
Yes.
All righty, so y'all, here we go. We're going to solve c squared minus 7c minus 30 equals 0. So we can go straight to our parentheses because we definitely got a trinomial here. We'll have a c and a c. What kind of signs would y'all put inside these parentheses?
Opposite signs.
Opposite signs, because that thing is negative. All righty. So find me factors of 30. That'll equal 7 when you subtract.
I'm 10 and 3.
10 and 3. All right. So who's going to be positive? Who's negative?
Wouldn't the 10 be negative?
10 would be negative. Good job. Makes the 3 positive. Because remember that larger number, when you add them, negative 10 and 3 give you that negative 7. All right, y'all didn't remember the rest of this is just adding and subtracting, getting these c's by themselves. So I subtract 3 and add 10. But y'all, do you agree? If you can get it factored, all you're doing is changing the sign of these two numbers to get your answers. So doing all this is not what I would call necessary if you realize that all we're doing is changing those signs to get them answers, okay? All right, so let me do one with a number in front of this thing. How about a 3t squared minus 13t minus 16 equals 0. All right, so what I'm going to do, I'm going to show you how I do these ones. Because when you got a number in the front, I don't like to do the guessing like 3 here and 1 here type stuff. So y'all watch what I do. So since I got a number in front, I'm going to take the 3 and multiply by the 16. So 3 times 16, if you multiply, is a 48. So what I need is to treat the 48 like it's my last number now. Now remember, that thing is negative, so that means I want factors of 48 that subtract to get 13. Now we also know since that last one is negative, one of these is positive, one of these is negative. So y'all, what factors of 48 will subtract to give me 13? Well, y'all, I used them right here, didn't I? 3 times 16 is 48. 16 minus 3 equals 13. So my two factors will be 16 and 3. All righty. Middle number is negative. That means the larger factor here will be negative. So the 16 is negative. The 3 will be positive. But y'all, I can't put these numbers in here yet. I got to do one more step. Since I used that 3 to multiply by the last number to get to 48, when you get your two factors, you got to divide both them by 3. And try to reduce it if you can. So the question is, negative 16 over 3 does not reduce. So that means this one has a 3 in front. So it'll have a 3t. Whoops, I put it on the wrong one though. But that's a minus 16. So this one should be 3t minus 16. This one you can reduce. A 3 over 3 will reduce to a 1 over 1. Which means this one has an x plus the 1. So remember, the x is always with the bottom number. The sign and number go to the ends. So at this, so question?
Do you mean T?
Yeah.
Oh, that's a t, my bad. So I got a 3t minus 16, I would set equal to 0. And then a t plus 1, I would set equal to 0. But y'all watch what's going to happen on this. To solve this one, I'm going to add 16 and divide by 3. So you get 3t equals 16. Divide both sides by the 3. So that cancels. I get t equals a 16 over 3. Well, y'all guess what? Well, I had a negative 16 over 3. So if you can get it to the reduced fractions here, if you just change these signs, you got the final answer. This was a positive 1. Well, y'all up here, I'm going to subtract 1. And I get a negative 1. So if you can at least get to these two fractions right here, change the signs and you'll have the final answers. So y'all, that was a little tricky because the number in the front, I don't think they do a lot of numbers in the front with y'all in foundations. Probably like one day of it and it was it. All right, so let's move to some more. So this one has a 4x squared minus 28 equals 0. Oops, let me pull that up. So notice you got an x squared term, but you don't have an x term in the middle. But you got another number. So really the easiest thing to do on these is solve these by taking a square root. So to solve this, to take square roots, I need to get this x squared all by itself. So the first thing we'll do is add 28 to both sides. You're going to get 4x squared equals 28. Now, I'm going to divide both sides by 4 because I want that x squared totally by itself. So those cancel and I get x squared is now a positive 7. So when you got x squared equal to a number, we solve that by taking square roots. So I would do the square root of x squared equals the square root of 7. So y'all, what's going to happen? Remember that radicals cancel the exponents. So I get my x. Anytime you take a square root, you got to account for a positive and negative answer. So y'all, here's my question. Does 7 have a square root?
No.
So I would just leave that a plus or minus square root of 7. So let me ask y'all this. Are y'all familiar with the plus or minuses?
Honestly, I've never seen it before.
All right, so here comes some more recall. What is the square root of 4?
2.
All right, that's one answer. What's the other square root of 4? What
Negative
else?
2.
What did you just say?
Negative 2.
Negative 2. Remember, negative 2 times negative 2 equals 4. 2 times 2 equals 4. So that's why when we do square roots like this, we say, well, that could be a positive or negative 2. That means that plus 2 is the answer like we got here. Also, negative 2 is the answer. So remember, any positive, like signs equal positive, right? So it's either 2 positives or 2 negatives. So y'all try this one. What's the square root? 25.
So that's 5 or negative 5, negative 5.
So there you go. Or you can just use a plus or minus 5. So the plus or minus is sort of shorthand for writing both those answers. All right, y'all, let me teach y'all about, so I'm going to recall y'all on something else you might see later. What's the square root of a negative 4? So you can't do that one in the real world, can you? Because 2 times 2 is positive 4. -2 times -2 is +4. So what you got to do to this one, you got to break it apart into a square root of 4 times a square root of -1. So let's do these by one at a time. What's the square root of the 4 going to give me?
2 or -2.
So I'm going to use plus or minus 2. So in the real world, we cannot take the square root of -1. So back in the day, Mr. Newton and all them guys said, well, if we get a square root of -1, we know we can't do that in the real world. So we're going to replace this square root of -1 with that little I. That little I stands for imaginary. So you would come down here, square root of 4 gives me plus or minus 2. Can't take the square root of -1, but I'll replace that with that I. So if you see a 2i or a 3i, that means they took the square root of a negative number. So let me try y'all with this one. How about the square root of a -81?
Plus or minus 9, right?
Oh, you're so close. Plus or minus 9. Keep it going.
-9?
No. Well, remember, I got a negative under here.
Oh, yeah, okay.
There you go. So it's going to be a plus or minus 9i. So if it's negative under a square root radical, those answers got to be imaginary. Because in the real world, like signs, they're not going to give us a negative, okay? All right, so y'all want one more just to make sure. Square root of a -64.
So it's plus or minus 8i.
And there you go.
Okay.
All right, y'all, let's look at 5. It's the same thing. 3x squared equals 6. So once again, I want to get the x squared by itself because I don't have an x term in here. So I'm going to do the same thing we did there and take square roots. So really the only thing I got to do here is divide both sides by 3. So I'll get x squared equals a +2. Take square roots of both sides. That's going to give me my x again. That'll be a positive or minus. So y'all, can we simplify the square root of 2?
No, outside of putting the imaginary I.
No, so since it's not a perfect square, you just leave that 2 in there and be done. Alrighty, so let's see. Oh, I like this one. All right, so number 6, 5x squared plus 10 equals 0. So once again, it's the x squared, so I'm going to get the x squared by itself again and do the square root stuff. I'm probably going to move this down a little bit. So we start out by subtracting 10. I get my 5x squared equals a -10. Divide both sides by 5. So I'm getting x squared is a -2. So y'all remember, now that I got the x squared term by itself, I'm going to take square roots. So that's going to give me my x. This will give me my plus or minus. So y'all, here's the thing. We know from earlier we can't simplify the square root of 2 part, but I got to do something with that negative at least. That negative is going to be an I. And y'all, usually, if I know I got the radical left in my answer, I'll put that little I out front and then put my square root of 2. What happens if you put the I behind it? Sometimes y'all leave it like this, but accidentally put the I underneath it. If you put the I underneath it, it'll mark that wrong. So if you want to do it that way, you have to put the plus or minus square root of 2, arrow out of the radical, then put the I. If the I is not under the radical, it'll take that answer, okay? That's why usually I put it in the front, then I won't have that confusion. But if it's under there like that, with the 2 like that, it will mark them wrong every time, okay? Howdy, y'all, so moving on. Oh, so that was number 6, I think. So 7 here is x squared plus 81 equals 0. So if you notice, there wasn't but maybe 2 or 3 that you had to actually factor to solve. These ones I'm all, since I don't have the x's, I'm just hitting them with the square root stuff. So get the x squared by itself by subtracting 81. X squared equals a negative 81. X squared is by itself now, so we'll do the square roots. That's going to give me my x. So y'all, what does the square root of that negative 81 going to give us?
Is it plus or minus 9i?
Plus or minus 9i. All right, y'all. So the last part of the support wants you to know this, is that the zeros are the solutions to quadratic equations. And quadratic equations got those x squared terms, okay? So they got the x squared term is the highest exponent. So zeros are the solutions, and that's because when we find the solutions, we're setting them equal to 0, right? So that's why we sort of call them zeros. But here's another thing about it. These zeros, the zeros are equal to the x value of the x-intercepts. So remember, x-intercepts is where it crosses the x-axis. So if I know the zeros, I can find the x-intercepts. Remember, x-intercepts have to be written like an ordered pair. So y'all, let's see. I'm going to draw a picture. And let's see if we can answer this. So I'm going to draw me a graph. Oh, and I'm probably going to go out about 5. All right, let me see. So I want this to cross right here and right here. And we're going to draw a parabola sort of connecting them. So for this one, part A, I want to know the x-intercepts. And then part B, we're going to find the zeros. So the x-intercepts have to look like ordered pairs. And remember, if it's an x-intercept, the y value will be 0. So the first x-intercept is right here at this point. So that's what, 1, 2, -3. So the x-intercept would be -3, 0 for the y. How about this one?
Just 3, 0.
3, 0. So remember, x-intercepts have to look like ordered pairs. Now the B part of that says the zeros are blank. And we use commas to separate these answers. So remember what we said up here, the zeros are equal to the x value of the x-intercepts. So your zeros would be -3, comma, +3. All right, y'all. So you got two doing this. One will be sort of shaped like a U. The other one, I think they got flipped upside down. But remember, all you're looking at is these x-intercepts for your points and your zeros, okay? Because remember, if you're on the x-axis, what is your y values? What is the value of the y coordinate? So right, here's 1.
0.
It's going to be 0. So that's why another reason you call them zeros, okay? All right, y'all. So the last thing they wanted me to show you for the support is a problem using the quadratic formula. Also, y'all should have got an email from me today about this quadratic formula. I sent y'all a file and a video showing you how to put that file into your calculator to give you the quadratic formula. Because by hand, this one's a tricky one. But the quadratic formula is used to solve equations of the form ax squared plus bx plus c equals 0. Now, the b can be 0 or the c can be 0, but the a has to be any number other than 0. So I can find the solutions. So the solutions are given by the formula x equals -b plus or minus the square root b squared minus 4ac all over 2 times a. Now notice, when you start this, everything has to be on one side equal to 0. I figure out a is in front of the x squared term, b is always in front of the x, and c is always the last number. I plug it for my b, my a, and my c. Now, most of the work is going to be figuring out that little radical there, okay? So let me show you one for support. When we come back Thursday, the college algebra portion is really heavy using this quadratic formula. So if you're not good at it after tonight, you will be after Wednesday, okay? So the support example has a 2x squared plus 2x equals -5. Well, y'all, the first thing I noticed here, I need a 0 on this side. Right? We got to have everything on the left side equal to 0. So since this -5 is on the right side, I need to move it by adding 5 to both sides. So the 5 is not going to add to anything here. So I'm just going to put it in order. My 2x squared plus my 2x plus my 5 over here, -5 and +5. Now give me my 0 like I needed. So let's pick out our A, B, and C. A will be 2 because it's in front of the x squared term. B will be 2 because it's in front of that x term. C will be a +5. So I got A, B, and C. Now I'm going to plug them into this formula. So I got my negative, and then I'm going to put in my 2. Then it's plus or minus square root 2 squared. So I put my, anything I square, I'm going to put in parentheses. Because if you put a negative number here, when you square it, it's got to be positive. And you can't punch that -2 and square it on a calculator. Remember, you got to use parentheses. So if my B was negative, I would definitely 100% put that in parentheses. But y'all ain't gotta worry about it, it's positive 2. All right, then I got minus 4 times A, which is 2, and C, which is 5. All that's over 2 times A, which was 2. All righty. Y'all, for most of the problem, I'm just going to be under the radical working, other than I know what 2 by 2 on the bottom will give me. So I got my negative 2 plus or minus 2 squared. 2 times 2 is 4. And y'all look at this side. You got a negative 4 being multiplied by 2 times a positive 5. There's only one negative on the right side. So the right side will stay negative. And let's see what we get. Negative 4 times 2 is negative 8. Negative 8 times 5 is a negative 40. All that over 2 times 2 is 4. All right, y'all, so bring down that negative 2 plus or minus. Now, the reason this plus or minus is here is because of that radical. Remember, all the stuff out of the radical can be either positive or negative, okay? All right, y'all, so let's see what we get. 4 minus 40 is a negative 36. All that's over my 4. All righty, so the next thing y'all need to do is figure out what the square root of negative 36 is. So what is the square root of that negative 36, y'all?
Plus or minus 6i.
Plus or minus 6i all over my 4. Y'all, I'm really close to my final answer, but notice all 3 of these numbers on the outside will divide by a what?
Factor of 2.
They're all divided by a factor of 2. So negative 2 divided by 2 makes that a negative 1. Plus or minus 6 divided by 2 gives me 3i. 4 divided by 2 gives me a 2 on the bottom. All right, so they want these in what we call A plus BI form. That means you got your real number and then your imaginary number. So the negative 1 over 2 part of this is the real number. So we would write negative 1 over 2. Then do our plus or minus. The imaginary part is going to be 3/2 and then your I. So when you got imaginary answers like this, they like to split it apart and put it in what we call complex number form. You got the real part and then the imaginary part. Now you could put the I on top of the fraction with the 3 and do a 3i over 2. It should take that also, I would think. But yeah, this is what they mean by A plus BI form. They like to split the fractions apart and have the real number and then the imaginary number. So y'all, we get to play with this bad boy. Quadratic formula come up Wednesday. And I think they'll even have 1 or 2 where we got a factor, okay? All right, so if you don't get this part of it tonight, you will by Wednesday. Main thing is on the support, get good at doing this square root stuff and some of those where I was factoring, okay? All righty, y'all, so I'm gonna stop that share. All right, so let's see. I guess we're at the point where I need to see if y'all have any questions. Hey, Alvin, can you hear me? Jonathan? I guess not. All righty, y'all. So let me quit that recording.